So today we have Ananda and Rafie joining us to speak about catching WordPress 0 days on the fly. So thank you very much, guys. Take it away.
Yes. Yeah. Hello, everyone. Today we're gonna present a talk about catching WordPress 0 days on the wild. First, let us introduce ourselves. Who are we? So we are both from PatchTech. We do security research on open source, especially on CMSs. Currently, we work on WordPress, Joomla, and Drupals for most of the part. My name is Rafie Muhammad, which is a lead security researcher at PatchTech. And then we have my teammate here, Ananda Dhakal, who are also a security researcher at PatchTech. The agenda for today is first, why WordPress, and then second one is introduction to WordPress SVN, the tool architecture overview, real-world findings, and also the closing thoughts. The first section is why WordPress. I mean, why we want to target WordPress in the first place. So, yeah, WordPress is still superior in terms of websites. It powers 43% of websites in the world. In the CMS market, it also have a share of 63%, at least in the 2024. It's also open source. Of course, it's PHP, so it's easy to familiarize. But some of you may be asking why WordPress again. I mean, yeah, the first point is almost every company has public-facing web, which mostly will use a CMS. And then WordPress is also like the leading CMS market. The second one is WordPress security is quite critical for especially hosting company. So we have cases of so many companies have a concern on WordPress security and on how to protect their websites from vulnerabilities, especially in WordPress. And the third one, in case you are wondering, WordPress in some cases, which might be not as critical as it states, but yeah, it still can act as initial foothold for attacker to gain more privilege to other area of the company. So yeah, we move on to the understanding WordPress ecosystem. So we have three parts of WordPress. The first one is the WordPress core itself, which is like the main app of the WordPress. And then we have WordPress plugins and themes. Currently there are 59K plus number of plugins in the free repository and also 12K plus themes in the repository. So everything is hosted on the WordPress SVN repository. Next is introduction to WordPress SVN. So if you're not familiar with SVN, it's basically like a centralized version of control system for managing core plugins and themes. So basically it's just Git for WordPress ecosystem. This is the example of the web view of the WordPress plugin SVN. This is one of the most popular plugins in the WordPress, which is Elementor, which we can use to build like custom widgets and modules for website view. We have some endpoints, which is like branches, tags, and also the trunk. So if you're not familiar enough with SVN, trunk is basically like the main branch on Git, and also the tags and branch, you also have that on Git. So we also have WordPress track. So bug tracking, it's for bug tracking and project management to track development and also tickets and also source code change. So basically, in short, it's a go-to place for a fresh vulnerable code for us to find. This is the example web view of the WordPress track. So you can access it for plugins, plugins.track.wordpress.org. You can browse all of the tags, branches, and trunks for all of the plugins and themes on WordPress. So yeah, we move on to the tool architecture overview. So basically, we just built like a simple script for our internal research to do this. So basically, first we detect a SVN repository change from WordPress, and then we search for a code pattern that could be yield a dangerous process. So we detect some code patterns and also dangerous functions used. And if there is any catch or match, and then we we create an alert to our Slack. All of this is wrapped under a threading process. So basically, we try to execute the script every 1 hour. So every 1 hour, usually there is like maybe like 50 or until hundreds or something change set to the text. So we need to implement some threading to catch all of the code change. The first step is to track the SVN change. So we first store the last process SVN revision locally. So revision is like a state where the plugins or themes currently at right now. It's just like a number stated for the revision. And then we compare it with the latest version, with the latest revision available in the WordPress. This is the example of the command tool that we use. We use the SVN CLI, which we use the SVN log -v, and then we compare the saved revision with the latest revision that are available on the WordPress SVN. The results mostly will be in XML, but it can be also in other formats. The next step is to check each of the SVN revision. So for each revision, we extract the plugin slug. The plugin slug is basically like identifying strings to make the plugin or theme unique. Because we have a case where plugin or theme have similar names or exact names, but it should have like a unique or different slug on it. And then we get the active installation count of the plugins or theme itself. Why? Because we only proceed forward with plugins or themes that have 5K plus active installation. Why? Because for efficiency, because previously we stated that WordPress have like 59K number of plugins and also 12K themes. So if we check all of the revisions without checking the active installation count, it will be really hard for our researchers to check all of them, and also it will be much more false positive on the results. And then we check each of the change files on the revisions. First, we skip the /text, /vendor, /branch, and also /assets. Why? Because we only want to focus on the /strung, which is like the main branch of the latest code pushed. So there is some cases where the developer of the plugins push the code directly to the /text. We don't want to catch that, because maybe they are only like changing the codes on older text or older branches. We only want to check the div code on the latest trunk. And then we also only process .php files, because in plugins and themes there is a couple of file types that can be pushed, for example XJS and also HTML. So we only need to check the PHP files. Yeah, and then for each change set, so a change set is like a compilation of code change in SVN revision. So we first open the change set file, and then we only process added lines, or like lines starting with prefix plus. This is the example of the added line or fresh code that pushed on the SVN repository. So we basically only want to focus on the new code, and then and not focus on the code that is being removed with a minus prefix. We only detect for the newly added code. And after that, we search for WordPress and PHP sensitive functions. There are a lot of WordPress or even PHP sensitive functions. This is some of them. So for example, we have wset auth cookie, which act like a function to set authentication cookie to users. We also have like the WP insert user, where you can create a new user with arbitrary role. And we have a bunch of PHP sensitive functions. We have a list, or at least like the vulnerabilities types of WordPress in our Academy site. You can access it with patchstack.com/academy. Yeah, and if it match, and then we get the change settling, and then we trigger a Slack webhook to our Slack channel. All right, now we're gonna move to the findings in the wild. This will be presented by Ananda.
Hello. All right. So basically, to summarize what we've done till this point, we're basically tracking the ESPN repository for all the WordPress plugins. So we're tracking all the changes, and we're basically looking for sensitive functions, and we're creating an alert on our Slack if we find the one of those listed sensitive functions in the change log. So we did this. We implemented this into our Slack, and let's move on to some of the findings that we came across with this tooling. So starting off with an account takeover vulnerability. So we got this the Slack alert that says like the passport policy manager with more than 5,000 active installs is using those WP set auth cookie and WP set current users. So the code was basically pushed in April 2, and we were able to get the alert 1 day later. So looking into the change log, we came across something like this. So basically the add action in it is like an unauthenticated hook, which basically any user can access the hook. So it is hooked with the YAML ppm pass to login redirect function. So looking into this function, we came across the nonce that is being done, which means we looked into like where this nonce is being generated, and we found that the user has to be logged in order to access this nonce. So even though the hook can be created unauthenticated, we would need to be logged in order to like move forward inside the function. So moving forward with the code, the function is basically taking in a user ID, and it is just setting the user. So we basically log in as a subscriber or like list privileged user and get the nonce. And what we do is we just supply the user ID, YAML ppm underscore user ID, and then we'll be logging with whatever user ID we supply. So basically this would lead to a complete account takeover of any user we want. So yeah, that was it for the account takeover. And moving on, we've got a PHP object injection. This is a particularly interesting case because this CV, this vulnerability entry on WP Evently plugin was found and then patched. So it was vulnerable till 4.3.6 and got patched on 4.3.7. And this is how they patched the issue. They basically commented out the vulnerable function. So we're not to the Slack alert point yet. So one day we get the Slack alert that says on the plugin just pushed a unserialized function into their code. And yeah, we were able to like catch it in like 30 minutes of them pushing the code. And when we looked into this function, we figured out that they removed the comment, which is a good thing. But as we moved across, we found out that they reintroduced the vulnerable code. So basically what happened was we reported them the deserialization vulnerability, they patched it, we marked the Shivi as patched, and after some time, they reintroduced the issue. So yeah, we had to report it to them again and convince them to fix it, and hope that one day we'll not get the same alert again and they're vulnerable again. So yeah, basically for POC was an unauthenticated POC, and we do have a gadget chain for WordPress core, so it would leak to another RC. So moving on, we've got a arbitrary plugin installation. So yeah, this is also a bit interesting case because you can see that there is unlink and file put content. We got the alert for that particular case, and yeah, this was even less than 20 minutes. Yeah, around 23 minutes, we were able to catch this. So the interesting part about this is that you can see unlink and file boot content were detected by our scanner. But this is the vulnerable code, and there is no trace of that. So what happened here was that the scanner found the use of those functions, but there was vulnerability in a different part of the code. So WP ASX install requirements. So if you're not aware, WP ASX hook basically means that any subscriber user or any logged in user would be able to call it, and they're just taking in the slug, and they're installing the plugin of whatever we supply into the WordPress site. So while it might not sound really impactful, but there is a catch. So there are a lot of malicious WordPress plugins like malwares that are pushed as well in the WordPress repository. While WordPress internal security team does their best to remove those from the repository, the catch is that in their ESPN repository, those codes still live, which means we would be easily able to install those malwares and able to easily access or get RCE. The other way one would exploit this would be to get one of the vulnerable plugins with really low installation, which is not a big deal at all to find. Plugins that have like less than 10 installations surely have pretty critical issues. So you just want to install that plugin using this and take full access of the WordPress site. So yeah, this is what it took to install any plugin. You just provide the slug and that's it. So one more case is an unauthenticated account takeover. So again, we see WP set auth cookie and set current user that are being used by this plugin. And when we look at the change log, we see that it's basically checking if the user is logged in, and if it is, it's basically setting the user. I'm not sure why they are doing that, because the whole point of that function is to like log in, and there's no need to check if the user is already logged in. But that's not the focus. So if the user is not logged in, what they're doing is they're checking for the user ID, and if it's not empty, they're setting that as the user. So what we need to do here is we just need to trace the user ID parameter and see if we can somehow populate the value or access the variable. So yeah, so that's what we need to do. And this was a pretty complex chain of issues, and due to some time constraint, we're not able to add the full code here, but you can check the article. So what we did was we traced it, and the function was the code was added in update card data function, which was called by handle value token, which was called by the post REST API request post/payu v1 get shipping cost. So we'd have to just pass the user ID in that post request, which would eventually flow down the code and trigger the account takeover. So if you're interested, you can check out the blog as well, because it's a bit long, long chain of issues. So yeah, the last one for the cases is arbitrary file upload. So there's a small catch here. The code was pushed in March 21, but we got the alert on April 3. So why did this happen? So at around like 19th of March, we stopped getting the alerts, and we were like, oh shit, developers have suddenly stopped using dangerous functions. They are suddenly aware that of the risk that they create. And we're like, it's been a week and we still don't see any alerts. And we're like, okay, they're really doing great. Or everyone suddenly went on a holiday. But after 10 days, we figured it's a problem of ours. So we had to look up and check that our tool had actually stopped working. So it took us like 12 days to catch this issue. So yeah, it's pretty simple. Instead of using like built-in WordPress functions that is secure by default, they decided that they would use their own custom, uploading functionality without any checks at all. And Yeah, but looking into the function, we found that it requires edit post permission, which is relatively high. It's like you need to be at least a contributor user, which is kind of high, but not that high. You know, if you write articles for a company, it's normal for you to have a contributor permission, and if you had that permission, you'd be able to upload a web shell and get RC. So yeah, that was basically the edit code later on, which didn't exist in previously. So yeah, this request would basically give you a web shell. You just need contributor cookies. So moving on, we didn't only see vulnerabilities getting introduced in the chain set. We noticed a lot more going on, and which we'll get into. So yeah, one day we got this alert and we were like, okay, a lot of includes, so there might be some Yalify. We might catch a couple of them. But when we, when we looked into it, we figured out that they were actually, patching some already reported vulnerabilities. So not only we got to see like, the vulnerabilities getting introduced, we also got to see them getting patched, which is a good thing, but a bit sad for us. So, so we had this alert popping up, but we were not able to take it due to being really busy with other stuff. And we checked this alert after like 1 week, and yeah, it was vulnerable to CSRF, to truncate logs, which is not particularly severe issue, but still it was something that would get a CVE ID. And when we checked the latest chain log, the code was removed. So they basically, introduced the vulnerabilities 4 days before we checked, and they patched it 41 hours before we checked. So yeah, the life cycle of that issue was really, really low. So yeah, now that we implemented the whole thing, we looked into these entries. This is not like while this is a pretty good starting point to get really interesting plugins you want to look into, because like there are 59,000 plugins, right? So it's a mess to select what WordPress plugin you want to hack on. So while it indeed helped us to get initial foothold on what we want to hack, or like or there were cases where we were just able to just open up the changelog and boom, that was it. But there are some problems and maybe future works that's needed for this. And the major problem with this approach was obviously false positives. So we got a lot of false positives because of the fact that even if you did a simple include with like constant value, which user would not be able to control at all, it will still generate an alert. So while it didn't take a long time to triage that, it took maybe less than 30 seconds to look into those alerts, but still the number of false positive is a bit concerning. And since we're only checking for like specific functions only, and we're not like going for the SAST scanning style, we are pretty limited in terms of what our tool can give us and what it can find. So in terms of what next, or what we can do to get something better or make this even better scanning tool, would be to obviously implement an actual SaaS tool there. So it's like basically CI/CD pipelining the whole WordPress ecosystem. So that's something we're planning on, and we'll see if how good that works out. And yeah, so it's the age of AI, so we obviously gotta sprinkle a bit of AI everywhere, right? So what we're thinking is to let AI do some of the triaging as well, which has not worked particularly well, because it's like, I mean, we tried with the LLMs, but it's basically summarizing that, which takes us nowhere. So, but still there are things that we can do, tweaking around as well, to see if we can actually get something. So yeah, that is also on our radar, which we might work on soon. So that's it for the talk. Thank you.
Excellent. Thank you very much. And we have plenty of time for questions if anyone's got.
Hello. By the way, nice talk. So I have two quick questions. When you say a lot of false positives, can you give us a rough ratio out of 100 Slack alerts that you get? How much are false positives to true positives?
Maybe around 80% of them are false positives.
All right, okay.
Yeah.
So my second question is, since we are doing a SaaS-based scan for a well-known, let's just say UL or whatever WP_set user, and I know there's some improvement for AI, which can basically check the logic of the code. So let's just say if there's a function that has a vulnerable code in it, but that gets sanitized later on down the line, so that part can be detected by AI with the improvements of LLM. The core question I want to ask is, what are you guys doing that the WP or WordPress codes team can't do? So the process is pretty simple, right? Just search for the SVNs, whatever new code change is there, scan it out just using a SaaS model, and look into it if it's a true positive or false positive. So why isn't the WordPress core team doing it instead of letting it go in the fly kind of a thing?
Yeah, that's a good question. I think it would take them a lot of resource to actually do that. Since we Tech, our full-time job is to look into WordPress security, so it makes sense for us to do it. But WordPress internal team is already flooded with a lot of stuffs because there's this case when we cannot contact a WordPress team, right? So we forward it to WordPress internal team. So they're already flooded with, even with just that. So they don't have a lot of resource. And yeah, maybe that's not their number one priority as well. They mostly focus on core stuffs. So that's why they might not want to allocate a lot of resources into that.
All right. And one last question, sorry. So how good has been with WordPress core team the CV process? Let's just if you find something, how good has it been till it goes to triage and you get a CV assigned? I have seen a lot of people complaining with WordPress that we do find an issue, but mostly the WordPress core team comes and say hey, the developer has stopped maintaining it, so you won't be assigned a CV for it because it won't be patched. One way is I don't think there's much logic to it, but that's what I've heard on the social media, or at least Reddit is full of it.
I mean, we do assign CVs even if the plugin is abandoned, so I'm not sure. Maybe they're at the wrong place.
Thank you.
Yeah, hi. So obviously there's a point in time where you started monitoring, right? And everything before that will not show up in your alerts. Is there any idea that you might have to apply what you're doing here to already existing vulnerabilities?
Sorry, I didn't get your question.
So you're alerting on anything which is being committed, any new commits into SVN, but everything before you started monitoring that's already vulnerable will already still be vulnerable now if they're not changing it, if it's not being updated. So is there any way for you to look back at past commits, that sort of thing?
Yeah.
And is that something you're looking at doing?
Yeah, I mean, it's possible to go all the way back because everything is in the SVN, but I do not think it would be a very, efficient way because over the time, a lot of vulnerabilities have been reported in WordPress ecosystem. Recently, in the last 2 or 3 years, due to bug bounties and everything for WordPress, and yeah, I mean. Given that there are a lot of false positives and there are already enough, commits going on around in the recent days, I don't think, we will ever have a time to, go back in time and scan all those previous issues as well.
Yeah, fair enough.
Anybody else? Excellent. Thank you. Hands together again.